hearts were seen in the experiment. So he didn't call this 34%, he called it 17. He didn't call this 16%, he called it 8.
Okay.
You see what I'm getting at here, friends?
I see what you're saying.
He didn't call this 26%, he called it 13. And he didn't call this 24%, he called it 12. Those are the actual occurrences that you had to see.
That's what we did last week in class.
I think we did, didn't we?
Yeah.
I was just looking at the words and it says, calculate the percent error for each experiment probability. So I was just using probabilities. But you'll see why numerically it's not going to change anything right now. If you use the actual raw counts here, what would you use for this? 12.5. Right? Because out of 50, you would expect 12.5 of each. Does it bother you that it's 12.5?
No.
It can bother you a little bit, but that's what it's going to average to every 50. Because it has to be equally spread amongst the 50 4 ways. And 50 split 4 ways evenly is 12.5 each. So then when you do the subtraction, you end up with 17 minus 12.5 over 12.5. Well, mathematically, let's put that right here, 17 minus 12.5 over 12.5. Well, if you multiply all of these numbers times 2, you get 34 minus 25 over 25. And all this is each number divided by 100. So since you're doing the same thing to all the numbers, they have to be equal in measure. So yeah, by all means, Manny, by all means do it that way, for sure. By all means do it that way. It'll work. That's just if you will be like kind of supple with the mathematics.
I didn't quite understand. I'm glad you did 24 because I didn't quite understand
What they were getting at.
Yeah, what they were getting at in 24.
Sure, it was
I
just-
didn't use the percentages because I never even finished 24.
Oh, that's okay.
What the hell, you know?
I'm glad you tell me things like this. I'm very, very glad you tell me things like this because I never hear those little what the hell, the little struggles that you guys have. So when you tell me this, I learn, okay, maybe I can adjust class to address that even more. So I appreciate that. I appreciate that.
I think even on the first part of the assignment, when they
Uh-huh.
were asking compare rates and stuff, I was like, what, is this an insurance company? Like, what the heck is
Oh, rate's a percentage.
Yeah, I was just like, it took me a second to figure it out.
Absolutely. And I think part of that is the fact that you guys are coming out of algebra-based classes where you very, very rarely talk about things like percentages and rates and proportions and probabilities. You talk more about like binomials and quadratics and things. And I just take it for granted, maybe improperly, that the word rate is common knowledge. We know what a rate is. It's a percentage.
Yeah.
That might not be correct, but I just take that for granted. So I like hearing that maybe it's not super clear. Okay, so we just did E4 too, didn't we? Sum the errors, what do you notice? You notice some awesome stuff. They sum to 0, yay us. What I'd love to do on Thursday, if we can do it, is do the error sum. The last quiz question on Thursday is calculate the percent error of your results that you simulate. I would love to sum all of our errors that day if somebody remembers to do it. Because I won't. I'm just saying this now. I won't remember. I'll forget that I even said this in 35 seconds. That's why I'm putting it out to everybody, because the chance of every single person in here forgetting it is almost 0.
Good idea.
So the chance of at least one person. Speaking of which, Kurt, what did you ask me about beginning of class?
Oh, yeah, I want to remind everybody to go on Blackboard and vote for the ASCOCC elections. I can't tell you who to vote for, but...
No,
definitely
but vote.
Go online and vote.
Can't tell us who to vote for, but you can vote.
Three candidates.
I vote for 3 candidates.
Not just candidate, or it won't count.
When I look over at you, remember, I'm trying to just tell you to say something together. That's what I'm saying. I increased it exponentially. Every person I say, so now you're all responsible for remembering this on Thursday. And I'm not. Okay. Okay, so friends, now that we've done E3 and E4, I think E5 and E6 are pretty clear.
Yeah.
So do you see how the setup's going to be the same? What do you think is going to be different?
The amount of times you draw.
Well, exactly. How many times did I draw?
1,000.
It looks like 1,000. Does it sound like 1,000?
Yeah.
It looks like about 250 each. What do you think is going to be similar, and what do you think is going to be different with the experiment when I draw 1,000 cards versus when I draw 50 cards? What do you think is going to be similar versus different? What do you think? What do you think?
You'll have a smaller percentage of error between them, because you'll have a larger number working.
Very nice harmony. The percentage of error within each suit. Over there it was 36%, 36%, 4%, 4%. overall, you're most likely going to see far smaller errors between. Let's take a quick peek. Let's take a quick peek. We're going to switch over to here. Get back on the TI. We'll just do one. We'll just do one here. Okay, so clear. We saw 242 hearts, correct? So Matt, I'm going to do it your way. I'm going to do it your way. We saw 242 hearts. We should have seen 250, so we were off by 8. Under by 8, correct? But we were expecting 250, so the percent error is under 3.2%. I say under, it's actually 3.2% too low, negative 3.2. So compare that to the 36% from before. I mean, it's an order of magnitude less. Why? Because you did exponentially more trials. And what's beginning to happen as you do more and more trials? Yes, it has to do this. Why?
I can't remember, but I know.
That's okay. Actually, Tiffany, this is not an easy question to answer. Why is it as you do more and more trials, the margins of error start shrinking down? Do you remember why? This is not a simple question. This hangs up my stat students all the time, too. Why? What's beginning to kick in? I'll give you a hint.
Ask the question.
No, I'm going to give you a hint to the answer. The answer is somewhere in these two lines. What's beginning to kick in when we do 1,000? Over time is beginning to kick in, right? Over time is beginning to kick in. 50 takes less time than 1,000 to do. So when you go to 1,000, you've got more of that over time taken care of. And so you're starting to see, I know it says 1/12, for us it's 1/4, because we're pulling suits out of the deck. So you've got more of the overtime happening. Yep, that's what it is. That's the big thing. If you take nothing else away from the study of probability, just understanding that when you see a probability, it's a rate over time. That's more than most Americans even understand. Seriously, I often tell my stat students, explain what it means. Explain what it means to have a 17% chance of injury to somebody that goes to Mount Bachelor. Suppose there's a 17% chance of injury at Mount Bachelor. Explain what that means to somebody. Well, people say, oh, it's a 1 in 6 chance. What does that mean? Imagine you're standing in your yard, trimming your hedges, and your neighbor walks over and says, man, I read this in the paper today. There's a 16 or 17% chance of injury to people that go to Mount Bachelor. That's really high. And then you have to explain that to this person. Explain what that means, a 16 or 17% chance of injury.
Well, do we have the people? How many people?
Exactly. Your neighbor doesn't know that, so what are you going to explain to him? How would you explain that to him?
I want to say, do we have 1,000 people? Do we have 100 people? Do we have...
It's the whole thing is average. The whole exact thing is average. What it means, essentially, and please realize, friends, I'm making this number up. I have no idea what it actually is. What it means is when you look at every single person that has gone up to Mount Bachelor, out of every 6, 1 has gotten injured. Now define injury. An injury could be a stubbed toe, ingrown toenail, sunburn. I mean, who knows how it's defined. But that's what it means. It means out of whatever sample they sampled, 1 out of those 6 professed some kind of an injury.
But I don't get how you can even believe something like that, because like for me, like before I lost all my health insurance, I was going to the mountain all the time, but my style of riding was way more riskier.
So
like
therefore,
90% of the
your
other people
rate
that
probably was underestimated by
I probably had at
60%.
least a 75% chance of getting hurt.
But
every
Matt,
time I went to the mountain.
you, listen to this, Matt is like the person in the back row, or one of the people in the back row, that when we rolled the die 12 times got 3 6s. You see what we're getting at here? You see what we're getting at here? This, Matt, because he was jumping slopes, saw whatever you were doing, you are covering for those who had no injury, and it averages out to 1 in 6. You said it yourself, because it averages. You hit the nail on the head, my friend. You hit the nail on the head. Matt getting injured more makes up for the hordes that don't get injured at all, and it averages out to 1 in 6. I mean, that's the definition of probability. When you line it all up, whatever sample you've got, that sample, however many got injured, that divided by the sample equals the percentage. That's an experimental probability. It's like rolling a die every time you go up there, according to the average. Now, that average might not apply to individual people. That's why, I think I've told you this story before. Did I tell you the story about my friend Jim and his wedding ring? I never told you about this? Okay, I'm gonna ask you a story. I'm gonna ask you a question. Suppose Well, I'll give you the background of the story. You know how we're in Bend, and it can snow on pretty much any day of the year. Like today, it might snow today, who knows. It was 34 this morning with the house. 34 this morning. My neighbors were like, oh my God, it's so hot. I'm like, just wait 3 days. It's Bend. Don't plant that yet.
Don't do
The
that.
snow's off of Black Butte. Don't plant that yet. It's not June. Anyway, and in June it might snow too. But here's the deal. It was one of those freak early snowstorms in like October. You know, one of those early ones that hits really hard. It dumps like 6 inches and it melts in like 25 minutes. So my friend Jim left class right at that time. Went outside, 6 inches of snow on his car, wet, heavy, sloppy snow, Cascade crud, you know, the stuff we usually get around here. And he just starts knocking the snow off his car, drives home, gets home, turns the car off, looks at his hand, wedding ring gone.
Oh.
So while he's knocking the snow off his car, your finger shrinks down a little bit, wedding ring flies off. He's in my stat class at the time. Comes back, says, Sean, I'm freaking out. You know, I lost my wedding ring in that snowstorm last night. I'm like, well, that's okay, dude. They didn't plow yet. So, and then the snow actually still was on the ground from the night before. Some of it had melted, but it didn't get above freezing enough to melt it all the way. So I'm like, let's just go out there and let's see if we can track it down. Well, they had plowed. I didn't think they had plowed. So now, where were you parked? Go where he's parked. And all the snow's pushed up on the side. You know, they dropped cinders down. And I'm like, well, dude, where were you? What were you doing? We tried to analyze where he was going like this. So we either went that way or that way. We go look, we don't see it. I'm like, I got this great idea. Let's just go get a metal detector. And we'll start passing it around. Well, little do I know, the freaking dirt in Central Oregon is metallic. I learned this day. I relearned it last summer. I dropped an Allen wrench under my deck. So I'm like, Max, watch how smart your old man is. We're gonna tie a magnet to the string and drop it down the deck. I come up with a magnet full of dirt and no Allen wrench. There's so much iron in the dirt around here, it's magnetic. Unbelievable. Drop the magnet out there sometime and pick it up. It's incredible. Half the dirt comes with it. It's all magnets. So anyway, metal detector's no good. So, what do you think the chance that we find Jim's ring is?
Slim and
Slim to none. Basically zero, right? I mean, metal detector's not going to work. That was our gimme right there. Even wait till it melts and look for it there. What we did was every couple of days, we take turns going back and looking. Like on the way to class, I'd leave 10 minutes early, and I'd go walk, and I'd kind of kick through the piles as they got smaller, It did snow once more, of course, to make it that much more challenging. But we go back every day, every other day. We'd alternate. 3 weeks later, I get a call from Jim. Dude, found it. Because the probability of finding it is extraordinarily small, but you can make your own probability in some ways by putting yourself out there day in and day out and day in and day out, and making your own likelihood. Sometimes you can. If it's based purely on randomness, you can't have anything to do with it. But if it's based on something like that, you can make your own probability. It's not pulling cards out of a deck anymore. It's I'm putting myself back out there. Jim's putting himself back out there. The chance of at least one of us finding it is actually pretty good at that point. Because we're out there every day analyzing, turning over the dirt again. If I turned it over and missed it, maybe he'll catch it next time. So yeah, I think everybody in here is thinking like, he's never going to find that ring again. But you keep putting yourself out there. You know roughly within the parameters it's flying, unless somebody else picks it up. But nobody else is looking for it. We didn't put a sign up that said, we lost my wedding ring. We just kept looking for it. 3 weeks later, Jim found it. So I guess the point is that it goes back to what Maddie said. When we hear a percentage that says, you know, there's a 1 in 10 chance of injury, and he's like, well, hell, I used to get hurt, you know, 90% of the time. Yes, but there are tons of people that didn't get hurt at all. And when all of that averages together, it averages out to this perhaps misleading statistic for one particular person.
And if he went skiing more than me, which I don't go.
He counts every single time, right? He counts every single time. Go ahead, Matt.
A couple of years ago, I'm a music student. I brought my guitar
awesome.
and stuff up here, and some guy broke into my car and stole my guitar and my pedal and a bunch of other gear and stuff that I was in there. And it was locked up and stuff. And so I called campus security and I was like, hey, I got, you know, somebody broke in my car. It was the middle of the day, like 2:30, 3 o'clock in the afternoon up by Pence. And I was like, blah, 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 got a thing, called the police. They're like, oh, well, we can't help you, like, blah, blah, blah. There's nothing we can really do. Like, that kind of stuff happens. You need to, like, go contact all the pawn shops and stuff. So, like, I got online, got a hold of all my friends up in Portland, Eugene, Southern Oregon, Craigslist did San Francisco, like, California, like, all this stuff. And then went to all the pawn shops and put my name out. which is like kind of like overtime type thing, like
Yeah.
getting that, shrinking that probability down. I didn't think of
All
it
it
like
is.
that, but
But it's what you're doing,
the
man.
next morning at like 9:30 or 10 when the pawn shop opened, I went around, did my rounds again, and found my pedal actually at one of the pawn shops down south of town, and they had the name of the guy that brought it in and his address. And so I was like, hey, that's my pedal, like blah, blah, blah. And they're like, oh, well, no, it's not. You don't have any like insurance or anything of showing that it's proof. And I was like, dude, I bought that pedal 6 months ago. I'm gonna go get the box it came in.
Good.
Came back with the model number and everything matched
Good.
up. Cops came down, like got his name, went to his house, got my guitar back, had my stuff back in
Maddie.
36 hours.
Maddie, thank you for this. Thank you
It
for
was
this.
so insane. Like,
It's not insane, it's
now that I
mathematics.
think of it,
Which, maybe it is insane, maybe it's insane, but Matt, he just mentioned two very important things. Number one, the overtime thing, perfect.
Yeah.
What else Maddie is doing, okay, so back to this guy rolling a 6.
Yeah.
Let's say that if Matt rolls the 6, he gets his pedal back. But if he doesn't get his pedal back. There's two ways to increase the chance of getting your pedal back, Matt. One is to keep rolling.
Right, more rolls.
Right? One is to keep rolling, which is like you said, Craigslist, your friends in Portland, Craigslist, Ben Craigslist, eBay, wherever you can possibly think to check to see where something will go up stolen. The other way is to make this denominator smaller and make the value of the fraction higher, which also inevitably is what you're doing.
When he was calling and things?
But the calling eliminates the possibilities. Once he knows, okay, I've contacted this pawn shop, my pedal showed up at that pawn shop, chances are everything else might be in a relative close region around that too. This is what cops do all the time. They basically put these feelers out, they take the phone calls in, call this number with information. Once they get the calls that come in, they say, suppose they get 10 calls that say this person is in this neighborhood. Well, the chance of all 10 of those people being wrong is essentially 0. So with every call that comes in, we're minimizing the chance that the person is somewhere else and lending more credence to the chance that they're actually where the phone call is coming in. So you actually use both of those strategies Max, to get your pedal back.
Yeah.
Did you get your guitar back too?
I got my guitar back, and my guitar was like, I bought it out of high school, and I have like thousands and thousands of dollars equipment because I've been playing for almost
Stuff's not
15
cheap.
years. It was like $2,500 guitar and like a $700 pedal, and I was like, that's grand theft. First of all, if you add them up, but they can't prove that,
Of course.
But then
Of
when the
course.
cops ended up calling me that night and saying, yeah, we went to his house, got your guitar back, blah, 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 and then they had me come down to the station, and
Right.
they took a picture with me of all my stuff, registered it with the national,
Yes.
Nice.
board or whatever, but then the cop asked me if I wanted to become a
That's
police
smart.
officer because I did
Because
better
you-
work than all
Because
of
they
them.
did better work than the cops.
Yeah. It was pretty awesome.
It's totally
But
awesome.
I
because
didn't
you
know
got
I
your
was
stuff back.
doing math, man.
Dude. I didn't know I was
I
doing
was
that,
just
man.
pissed off. I was just pissed.
What is the necessity is the mother of invention? Thomas Edison, I think, said that, right?
Yeah.
You invented what you needed at the time. You needed probability right then, and you invented it for yourself. I mean, essentially what you did, you made up probability when you needed to make up probability, man. Excellent, brother. Excellent. It's perfect. Perfect thing. Perfect thing. Cool? Let's take 5. Thank you very much, brother. We'd love to capture that. Audio, at least. Should have the camera on you. Take 5, yes. Give the guys some